Hello, and thank you for being here. I'm Andreu Girbau, and I'm going to be presenting multiple object tracking from appearance by hierarchically clustering tracklets. This work is a joint effort of the National Institute of Informatics in Tokyo and the Polytechnical University of Catalonia in Barcelona. The current dominant approach in multiple object tracking is tracking by detection. Given a video sequence, we detect all the objects in the scene and assign an ID to each object, propagating it through time. There can be different information available per object. Usually it consists on the timestamp of the frame where the object belongs to, the detection with position, width and height, and extra information. In our case, we gather the appearance features. By connecting these detections through time, we end up with the object tracks, which are characterized by an ID and the trajectory of an object throughout the video. In a nutshell, our method uses appearance to associate object tracklets through time using a sequentially guided hierarchical clustering. In the first step, we collect the detections and appearances of each object to track. Then, we group objects within a temporal neighborhood to form tracklets. We further cluster these tracklets in a hierarchical way, following the sequential nature of the video. Finally, in the last level of the hierarchy, we assign an identification to each cluster of tracklets, naturally leading to the object tracks. In this work, our contributions are the following. We explored the multiple object tracking focusing on appearance as the main source for association. We show that a fairly simple tracker, using off-the-shelf models and without optimization or post-processing, achieves similar performance to other, more complex state-of-the-art methods. Going into detail, we first extract data for all the frames in the video sequence. For each frame, we detect all the objects of interest, in this case pedestrians, and extract their appearance features. Projecting the appearance features into the embedding space and performing a naive clustering can lead to lots of identity switches and can be computationally expensive when lots of objects are present in the video sequence. For this, we first generate tracklets based on the appearance features. Given the set of detections within each time instant, we use a sliding temporal window to capture variations in the object appearance, and form the tracklets by clustering and using the cosine similarity between appearance feature vectors. To sequentially cluster tracklets in a hierarchical way, we introduce the concept of lifted frames, which are artificial time instants that contain tracklets instead of individual detections. The indexes of the lifted frame correspond to the current hierarchy level and its temporal indexes, here containing the tracklets with detections for the first position of the temporal window, and here containing the tracklets with detections for the second position of the temporal window, and so on and so forth. With this formulation, each tracklet within a lifted frame is represented using an extra superindex. We proceed to cluster tracklets following the sequentiality of the video. We summarize the appearance of each tracklet as their element-wise median and compute the cosine similarity between both. Once we arrive to the final lifted frame, which contains all existing tracklets, we proceed to assign an ID to each cluster, naturally generating the final tracks. To make the method more robust, we use the spatiotemporal coherence. For the temporal coherence, the goal is to make the fusion between tracklets harder but not impossible, so an object can be recovered after long-term occlusions. To do so, we consider the temporal distance between detection timestamps, and update the distance between tracklets by weighting it with a constant lambda t factor. For the spatial coherence, we make the fusion easier if two objects are close in space and harder but not impossible if they are far apart. This is useful when occlusions occur, as the object appearance can change a lot in a short time, or to avoid ID switchings when two objects are very similar. Again, we update the distance between tracklets with a lambda c factor corresponding to the object's closing space and a lambda f factor corresponding to further objects. We combine all the factors and end up with the final distance between tracklets. We tested the performance of our method in 3 different datasets. The first one, Mod17, focuses on tracking pedestrians in the wild. The second one, Mod20, follows the work of Mod17 and also tracks pedestrians in the wild with a much larger density of people in the scene and longer sequences. And the last one, Dance Track, where the setting is much more artistic and the main difficulties consist on the amount of occlusions and random movements between dancers. By comparing our approach to other state-of-the-art results, we observe that similar tracking performance can be achieved by focusing on appearance between objects as the main source for association and with a much simpler technique without the need of any kind of post-processing when performing the tracking. To observe the evolution in the field, we include relevant results from the recent ECCV conference. Another experiment we conducted is related to the degeneration of tracking performance when reducing the amount of frames per second. Here, we show the first 20 frames of the original video sequence. We reduce the frames per second by using different sampling ratios on the original video sequence. For instance, sampling 1 every 10 frames, or 1 every 30 frames. And find that our method is more robust than other state-of-the-art trackers that might focus a lot more in the spatial and temporal information between instances of the same object. Finally, we show some visual results in the Mod20 dataset in the left and Dance Track in the right, where the same color corresponds to the same instance of the object being tracked. Our code is already available on GitHub. Thank you very much for your attention.